Module 3, Proportionality. Section 1, all about polynomials. In Module 3, we're going to talk about a thing called proportionality. And in this very first section, we're going to cover a thing called polynomials. We're going to define what they are, which you may remember from Algebra 1. And we're going to go through some special kinds of polynomials. For example, a monomial, what is that? A binomial, a trinomial. We're going to also define some other vocabulary words: degree, coefficient, term, and leading coefficient, leading term. And we're going to also recognize when do we have a polynomial and when is it not a polynomial. So let's get right to our first slide. So when are polynomials even useful? I wanted to start with that right off the bat here. And you can see this is actually called a polynomial down here. And here is a general form where we have a bunch of letters and stuff. But this particular polynomial actually makes this fancy graph here that looks a heck of a lot like a roller coaster. So when mathematicians and scientists and engineers are planning out a roller coaster, they're going to actually design it using a computer, and the computer's going to have to come up with the equation to draw this curve. And it comes out to be this crazy polynomial with an exponent of a 6. So here's an example of a polynomial in action. Let's go to the next slide. Now, a monomial is a special kind of polynomial. A monomial is when you have a single term. It's a number variable, a product of numbers and variables with whole numbers. So let's look at some examples. So for example, we could have 5x squared. That's a monomial. It's got a number out front called a coefficient. It has an exponent and it has a variable. We could even have something as simple as the number 8. That's an example of a monomial also. It's just a single term, just a single expression there. The term or the expression x plus 1 would not be a monomial because it has more than one term. You see, a monomial has to have only one term. That's why the prefix is mono, like mono e mono is one-on-one. So a polynomial that only has a single term, like these here, are called monomials. Let's move on to the next slide. We're going over quite a bit of vocabulary in this section. The first vocabulary word that I've already used today, and that is coefficient. A coefficient is a constant that's multiplied out front here. So for example, on this 5x squared y to the third, the coefficient would be the number 5. Just the number 5 and only the number 5 is called the coefficient on that term. The second vocabulary word on the screen is the degree. This might be new to you, or maybe you don't quite remember from Algebra 1. But the degree is how many variables make up this expression. Well, we've got 2 factors of x, we have 3 factors of y, and we have 1 factor of z. So you literally add up all the exponents. 2 plus 3 plus z to the first. There was an exponent of 1 there. The degree on this monomial is a degree 6. It's called a degree 6 monomial or expression. Let's move on. At this point, I would like you to pause the video and try to answer what the coefficient of this term is and what the degree is, and you can put them right here and here. And then the same thing for these other 3. Go ahead and pause the video and try to fill in these spots, and then I'll go through the answers. Okay, let's go through the answers. On this first expression, the coefficient, remember, is the constant that is out front. So the coefficient here is the number 7. Now, what is the degree? Well, the degree is how many factors of variables do we have in the picture here? Well, we have 2 factors of x, so that would be x squared, of course. So the degree is simply 2. A lot of students accidentally say x squared is the degree, but it's just the number 2. Just the number 2. So please check your paper, make sure you have the number 2 there. On this next example, looking for the coefficient here, it would be just the negative 13 that's out front. And the degree on this one is where you add up all the exponents for all the variables. So we have 6 plus 2. We have 8 factors of variables floating around, so we would call this a degree 8 monomial. On the next example, we have a k sitting there with a minus sign out front. So what is the invisible number that's out front? Of course, it's a -1. So the leading coefficient here, or the coefficient, is -1. And then what is the invisible exponent on that k? It's a 1. So this is called a degree 1 monomial with a coefficient -1. And then finally, the last problem here is actually called a constant. It doesn't have a variable, so that means it's degree 0. And then I guess we could say the coefficient is the number 8 because there's an invisible x to the 0 hiding there that we just don't see. It's there because anything to the 0 power is 1, so that's why it's a degree 0 with a coefficient 8. Let's move on to the next slide. So we've covered what a monomial is, but we haven't talked about this polynomial thing too much here. A polynomial can have all the same stuff we've been talking about, where you have constants and variables and coefficients, exponents, like in y squared. But here's the thing, with a polynomial you can combine multiple terms through addition and subtraction. Like this down here, we would say has 3 terms, and this is called a polynomial. The prefix poly means many. So this has many terms strung together with either addition or subtraction. That's what makes this a polynomial. Now, I do want to point out here, we're not allowed to have any division by a variable. So you can't have an x in a denominator. You also can't have the square root of x or x to the 1/2 power or anything crazy like that. It really just has to be nice round whole number exponents on the variables that are all in the numerator. And we'll look at some examples here in a second. Now, I've already mentioned this on the previous couple slides, but the word term is where you count how many monomials are strung together with plus or minus. So if you think about this as being a single monomial plus another monomial minus another monomial, term, this has 3 terms. So let's go ahead and fill this in. This has 3 terms strung together with addition and subtraction, and that makes it a polynomial, of course. Now you might remember talking about these terms that we're going to see here in a second back in Algebra 1 when you did foiling and factoring and all that kind of good stuff we're going to get to here shortly. When you have one term, that's called a monomial. So let's fill that in. So what is it called when you have 2 terms then, like the following example? It is called a binomial. The prefix bi, like in bicycle or biplane, means 2. So when you have 2 terms, it's called a binomial. Now what happens when you have 3 terms, like the following example? Here's 3 terms, 1, 2, 3, and we saw an example like this on the previous screen too that had 3 terms. Well, what is the prefix that means 3? We have mono, bi, the next one is trinomial. And anything bigger than 3 terms, we usually just call it a polynomial. But just technically, these are all polynomials also. So these are special names for some special polynomials. 1 term, monomial, 2 terms, binomial, 3 terms, trinomial. Let's move on. So on this slide, let's check to see your understanding. How many terms does this have? Write the number there. And what is that called when you have that many terms? Hopefully you said it has 3 terms and it's called a trinomial. Trinomial. And the next problem, how many terms does that have? There's quite a bit of stuff going on here. But it's actually only 1 term plus another. So a total of 2 terms, and that makes it a binomial. And what about the next example? Well, it also just has 2 terms. It's called a binomial. And the last problem, that has 1 term, and those are called monomials. So hopefully you got all those right. So that's how we use those terms, monomial, binomial, and trinomial, and the word term. Let's move on. So we talked about how to find the degree of a single monomial. Remember, we added up all the exponents, but this is different, so please be sure you're paying attention here. The degree of a polynomial is the highest degree that you see out of all the terms. So for example, just focus on this. What is the degree of this? Well, it has two variable factors. The highest exponent is a 2. So this would be degree 2. This term is degree 1. And this term is degree 0. So what is the highest out of all those? This would be called a degree 2 trinomial. We would call this a degree 2 trinomial. Let's look at the next problem here. Here we have x squared minus 2x to the third plus 4. So this is a degree 2 part, called a term. This term is degree 2. This term is degree 3. That biggest exponent I see is a 3. And then this term is a degree 0. So what was the biggest number I said? 3, 2, or 0? Of course, it's a degree 3. Degree 3 polynomial, we would call it. Now you may have noticed on the previous screen that some of the exponents were not in order. Like this one is nice and in order. We've got a second degree, first degree, 0. So the exponents are like counting down here. 2, 1, 0. That's called standard form. So let's see this other example I have hiding here. This is not in standard form. The exponent is a 2 here, and then this term has an exponent of a 3 and then an exponent of 0. So let's go ahead and rewrite it in standard form, and I want to point out that the minus sign is attached to the 2. So it's got to go with it. So we would rewrite it as negative 2x to the third plus x squared plus 4. That would be standard form for that polynomial. We simply rewrote it in standard form, and that can be useful so that we all write it the same way after we've done a big problem or something. We want to write it the same way, so we write it in standard form usually. Now on the screen we're talking about leading coefficients. Remember, these coefficients are these numbers, like 7 is a coefficient, 4 is a coefficient. I guess technically the number -1 is a coefficient here. Now when we're in standard form, there's this thing called the leading coefficient. It's way out front, and it's very obvious here that way out front we have the number 7. So that would be the coefficient. Now I want to point out the answer is not 7x squared. I was asking for just the coefficient, which is just the number 7. I do see this mistake done often, so that's why I wanted to point it out. Don't write 7x squared when I ask for the leading coefficient. 7x squared is technically called the leading term. It is the term that's out front, but it has a coefficient of 7. And the reason that has a special name is because it is very helpful to recognize what the leading coefficient is when you are graphing these things, which we'll get to eventually. All right, let's move on. All right, on this last screen, I just want to test your understanding of whether you can recognize what a polynomial is and what is not a polynomial. And remember, polynomials can have variables, but they cannot be in the denominator. The variables can't be in the denominator. The variable cannot be in the exponent or under square roots or third roots or other radicals. Also, exponents must be positive whole numbers. So for example, would the square root of 8x be a polynomial? Well, no, of course not, because the x is under a square root. Now what about this example down here? What about x times the square root of 2? Is that a polynomial? You might have said no, but it actually is. And the reason is because it's x to the first, and that's outside the radical. And then attached to it is the coefficient, the square root of 2, which is actually just a number. It's 1.4. So this is really 1.4x. So that is technically a monomial or a polynomial. Let's look at this next example. Would this be a polynomial? No, it would not, because there is an x in the denominator. It would not be a polynomial. And what about this problem here? Well, now I've changed it, and the x is on top. Now you might say, but there's a fraction there. That's okay. It's just 1/5 x plus x squared. So this is a polynomial. Let's take a look at this example here. X to the y minus 5x. Is that a polynomial? No, definitely not. You're not allowed to have a variable up in the exponent and still call it a polynomial. This is a very special function called an exponential. However, we're not dealing with those in this chapter. We're only dealing with polynomials, so we need to be able to recognize them. What happens if I replace the y with the number pi, 3.14159? Is that a polynomial? We've got a pi up there. Yes, it actually is. And the reason is because pi is just a number. It never changes. So as long as the exponent up there is a number, this could technically be a polynomial. Now, I was just realizing as I'm talking about this that I guess maybe this is not a polynomial because pi is an irrational number. So it is a number, so it's really close. So I guess some might say that it's not a polynomial. So I just caught that while I was going through this. All right, finally, let's just double back. So today we reviewed the vocabulary of polynomials and what it is. We actually just finished a slide where we were recognizing what is and what is not a polynomial. A monomial is a single term, binomial 2 terms, trinomial 3 terms. The degree has to do with all the exponents on the variables. Coefficients are those numbers, those constants that are out front. We also talked about a leading coefficient. And we also talked about terms and how to recognize they're separated by pluses and minuses. We also talked about the leading term. So hopefully this video was helpful for Module 3, Section 1. You can always go back and rewatch it if you can't get enough of it. We'll see you in class.